A mineral consists of an equimolar mixture of carbonates of two bivalent metals. Means there is a mineral which is having equimolar mixture of two carbonates and both are the carbonates of bivalent metals. One metal is present to an extent of 12.5% by weight. So the percentage mass of one metal is given clearly as 12.5. And if 2.8 grams of the mineral is subjected to heating, then 1.32 grams of CO2 was lost. Now we need to find out the percentage mass of the second metal. So here let us take the two bivalent metals as X and Y. So if X and Y are the symbol of the two metals, then what would be the formula of their carbonates? Definitely XCO3 and YCO3, isn't it? Similar to that of calcium carbonate and magnesium carbonate. Now, when these carbonates are decomposed, what are the products formed? It is the metal oxide and the carbon dioxide is released. And here again the metal oxide and carbon dioxide is released. If you are confused with this symbol X and Y, you can imagine magnesium and calcium. So two bivalent metals, calcium and magnesium. So their carbonates are MgCO3 and CaCO3, and when they are decomposed, we get corresponding metal oxide and carbon dioxide. So when we add this one, this XCO3 and YCO3 together gives XO plus YO plus 2 carbon dioxide. Isn't it? Means from 1 mole of carbonate of X and from 1 mole of carbonate of Y, totally we get 2 moles of carbon dioxide. This is the hint for working out the numerical here. And it is given in the numerical that 2.8 gram of the mineral on heating lost 1.32 grams of carbon dioxide. 2.8 grams of the mineral gives rise to 1.32 grams of carbon dioxide. Now, if at all we consider this much quantity of carbon dioxide, that is 2 moles of carbon dioxide, means 88 grams of carbon dioxide, how much quantity of mineral we need to take? It is nothing but 1 mole of this carbonate and 1 mole of this carbonate. And what is that one? When we express in terms of mass, it is the molecular mass of XCO3 plus molecular mass of YCO3. That will become the mass of the mineral required in order to give 88 grams of carbon dioxide. So that entire mass of the mineral is nothing but the molecular mass of the mineral or the molecular mass of the mixture, isn't it? So this is nothing but 88 upon 1.32 multiplied by 2.8. We get this value as equal to 186.66. And what is this one? This is nothing but the molecular mass or the gram molecular mass of the mixture or the mineral. Because this mineral consists of equimolar mixture of these two components. So in order to get 2 moles of carbon dioxide, definitely we require 1 mole of this one and 1 mole of this one. So totally this becomes the molecular mass of the mixture, that is 186.66. And here clearly given that the percentage of one metal is 12.5. So the weight of X is equal to 12.5% of the total mass, that is 186.66. And this value comes to be 23.33 grams. So weight of one metal, that is X, we got it as 23.33 grams. Now let us calculate the weight of the second metal. Now we know that the molecular mass of XCO3 plus the molecular mass of YCO3, this total is equal to 186.66, isn't it? Then as we know the X value is 23.33. So 23.33 and the molecular mass for this carbonate is 60. This is for the XCO3. Plus we need to calculate the mass of Y. So Y plus another 60. This is equal to 186.66. So on solving this, you get the value of Y as 43.33 grams. So we got the value of Y. We can calculate the percentage of Y, which is equal to 43.33 divided by total mass of the mixture, that is 186.66 multiplied by 100, and that comes to be 23.21%. That is the final answer, and that is there in option A. So what we have done here, first from this hint of 1.32 grams of carbon dioxide lost from 2.8 gram of mineral, we could calculate the molecular mass of the mixture, because the total mixture containing 1 mole of each carbonate together gives 2 mole of carbon dioxide, and we get that 88 grams of carbon dioxide from the 186.66 grams of the mixture, which is nothing but the molecular mass of the mixture or the molecular mass of the mineral. And after that, from the value of the one metal present to an extent of 12.5%, we could calculate the mass of X exactly, that is 23.33 grams. And as we know, this 186.66 is the total molecular mass of the entire mineral, which is XCO3 plus YCO3. As this value is just calculated here, already we know the molecular mass for carbonate. Substitute here, we will be getting the mass of Y, and then we can finally calculate the percentage of Y.